Hi all, and I welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Having uploaded part 1 of continuity and differentiability, where I have discussed continuity as well as differentiability concept. I repeat, continuity as well as differentiability concepts. Now, time has come to learn how to differentiate a function. So, I would like to call under this chapter what I am going to teach today as methods of differentiation. Okay, when I say differentiability, we are just trying to know whether a function is differentiable or not. Now, coming to let us suppose that we already assume that the function is differentiable. Then how are we going to differentiate that function, excluding first principle of derivatives, which you learnt in first PUC, is one where you are going to derive the result, correct? Derivative of sin x, cos x, tan x, and other functions. After learning that, we are going to learn different methods how to differentiate the given function. Okay, so let's continue with this, and just take the chapter name again. The chapter name is continuity and differentiability. Now, let us proceed. See, try to understand the concept first. Now we are on differentiation. In this part 2, let us suppose that I have got y given as y equal to f of x. First, understand the meaning of this. In y equal to f of x, this term x is known as independent variable. Independent variable, whereas y, which is equal to f of x, these are termed as dependent variable. When we are saying independent variable, dependent variable, if you talk about our real world problem, very simple it is. We all are depending on whom? Think. We all are depending on whom? Time. Whether we get up or not, 6 a.m. will come, means clock will say 6 a.m. Sun will rise. Right? No. It's not that since I have not woke up, sun will not rise. It is not like that, no? So we are depending on whom? Time. So time is independent factor and we are depending on it. So we are dependent variable and time is independent variable. So whenever we are differentiating any function, we are always differentiating with respect to independent variable. So here, as x is independent variable and y is dependent variable, when I'm going to say from here, differentiate with respect to what? With respect to independent variable. Who is independent variable here? X. So differentiate with respect to x. So the symbol, the notation will be d by dx. What's the meaning of this? I am finding the derivative with respect to x. But when I want to find the derivative with respect to x, who is the independent variable? And who is the dependent variable? Independent variable is x. Dependent is y. Similarly for this also. Okay. I hope till here clear. Okay. So let us proceed. So how are we going to read this? Derivative of y with respect to x. Similarly, derivative of f of x with respect to x. Now we have some other notation also for the same. We can also write this one as y dash here, or you can also write here y prime. which says that I am differentiating for the first time. Similar here also, it can be f dash of x. We should know the notation, that's very important. Should not happen now we are fixed with this too. In exam this came and we are in trouble. Okay. Now this is in general that just find the derivative. Let us suppose that I want to find the derivative at a particular point. Let us suppose at x is equal to a. Then in place of here, now how in question they will be asking, it will be like this: derivative of y with respect to x at x equal to a. Or they can also write derivative of y with respect to x. Two brackets are given, you can see here. Or it can also be given f dash of a. All the mean same. It means first find the derivative, then in place of x evaluate a. You have to evaluate for a. Okay. Many students think no, first you should substitute and then find the derivative. No, it is rate of first. What is the meaning of this? Rate of change of y with respect to x. Correct? No. So we want to know what is the change at this particular point a. So what is the change? First you should find the derivative, then evaluate at the given point. Okay. Now having understood this, let us try to go for formulas. First formula, okay, let's have list of formulae. List of formulae. And this formulae you have to memorize. Without that, we cannot go for differentiation. When I cannot go for differentiation, I cannot go for the next chapter, application of derivatives. And similarly, chapter number 7, integrals, then application of integrals. Anyway, application of integrals already uploaded in the YouTube. And since we had 4 formulas, I just asked you to remember those 4 formulas, sufficient. But differential equation is not the case. And one more thing, CET is not like this. CET is not going to be like this. No, this particular formula you remember enough. No, we want entire thing. You should be ready, passion for it to score high. Okay. Now let's proceed. Coming to list of formulae. The first formula which we have is derivative of x power n with respect to x is n into x power n minus 1. Purposefully I have given the power n minus 1 in the bracket because many have a doubt this minus 1 is power for x or the base, where n is any real number. It can be any real number. For example, let us take one example here. If I ask you to find derivative of x cube, very simple. In place of n, 3 is there. X remains x. Substitute here. Wherever n is there, 3. So 3 into x power 3 minus 1 or 3 into x square. That's it. Next, I would like you to remember this as a standard result. Derivative of x with respect to x. So the power is 1 here. Substitute here. In place of n, what do we have? 1. Put here 1 into x power 1 minus 1, which is nothing but 0. So 1 into 1, nothing but 1 itself. Therefore, derivative of x with respect to x is what? 1. No, don't say, both will get cancelled. It is what? Rate of change of x with, I repeat, rate of change of x with respect to itself. So when I want to have a change with respect to itself, surely it will be 1 because both are varying at the same time. Correct now? Next, third one. Derivative of root x. See, actually derivative of root x will get from here only. Take root, as you know, square root value is nothing but power half. So n is equal to half. If I substitute, I'll be getting 1 divided by 2 root x. I recommend you to memorize this because frequently we are going to use this result. Okay. Next, derivative of 1 by x. Again, this I can get, if I write this one as 1 by x, we can write as what? X power minus 1. So in place of n here, minus 1, substitute here, then we get the derivative of 1 by x to be, derivative of 1 by x to be minus 1 by x square. Obviously for these two cases, x should not be equal to, okay, let us not write any condition presently. Just let you learn the formulas. Okay, fine. So these are the 4 formulas on algebraic, nothing but there is no trigonometry involved in this. Okay, no? Fine. Make a note of this. Now let us move on to trigonometric functions also. Before that, some more will write it here. What is derivative of a constant? Any constant. Derivative of a constant is 0 because for a constant function there is no change. Example A. If I ask you derivative of 7, since 7 is a constant, answer is what? 0. Second example. Derivative of minus 2. Derivative of minus 2. Again minus, okay, I'll take minus root 2, irrational number. Again the answer is what? 0 because minus square root of 2 is what? A constant. Then we can have like this so many examples. Whenever you have got a constant, answer is what? 0. Next, what is derivative of a power x with respect to x? It is a power x into log a. Similarly, seventh formula, what is derivative of e power x with respect to x, the exponential function? This and this both are exponential function. Answer is e power x itself. What is derivative of log of x? Derivative of log of x with respect to x is 1 by x. Okay. Now, having understood this, let us move on to the next part. Now let us move on to trigonometric function. Before that, no, let you have a difference between first and sixth. So here also we have got base and power, here also we have got base and power, and here also we have got base and power. So how to differentiate, how to know that which formula to be used? First, see, x is variable, right? And n is a constant. So, okay, let's specify again. What is n? N is a constant. So, when to apply formula number 1? Whenever base is a variable, power is a constant. That's what you can see here. Whereas, you see this, base is a constant, power is a variable. So, for example, same question. If I take one example here, derivative of 3 power x with respect to x. Now I cannot apply this formula. So in place of a, I have 3. Why I cannot apply this formula? Base is a constant, power is a variable. So wherever a is there, replaced by 3. X remains x. So what I will get? 3 power x into log 3. That's it. Where the base is here, e. Let you remember that the base is e there. Okay. And actually this is special case of formula number 6. If I take a is equal to e, so here I'll get e power x, which we have got here. But log e to the base is 1. So that is 1 into e power x is e power x itself. Okay. Having understood this, let us move on to trigonometry. Moving on to 9th formula, derivative of sin x with respect to x is plus cos x. 10th formula, derivative of cos x with respect to x is minus sin x. 11th formula, derivative of tan x with respect to x is plus secant square x. Purpose of having plus also here I could have avoided, but I want to stress that it is plus, okay, not minus. Then 12th formula, derivative of cosecant x with respect to x is minus cosecant x into cot x. 13th, all this derivation is being done in first year PUC except 6th one, 7th and 8th. Okay, that was done in second PUC, but here now result is not required. We should learn the formulas. This formula should be learned by you by practice. Okay, it should be in your fingertips. It's something like no flow of water. Okay, like that it should be. Next, derivative of secant x with respect to x is plus secant x into tan x. Lastly, let us write it here. Okay. What is derivative of cot x with respect to x? It is minus cosecant square x. Now, whichever function I have taken, no, I have taken a simple function. What I mean to say is, I have not taken combination of more than one function. All are simple function. But coming to our second year PUC, we are going to have composite function. Composite function I have discussed in the chapter relations and functions, F composition G. F and G are any function. Now we are going to have a particular function for F and G there. Now let I give you the concept, and then for this formula, third and fourth, especially first and third, we can have a general formula. Okay, let us understand the concept behind. Let us try to make a note here. Focus. Is it visible there? Yes. See carefully. Pay attention. Derivative of. Okay, I think after I write it here, then again I can erase. Okay, not a problem. I write it here. That's better. Derivative of composite function now. Derivative of the first topic of second year PUC. Derivative of composite function. Composite, combination of more than one function. Derivative of composite. Okay, composite function. Now listen carefully. See, when I just talked about the notation, we had y is equal to f of x. And for this, I just said how to differentiate. Point number one, that to differentiate, this is the operator. Correct? Over. Now, in place of a single function, let us suppose that I have got combo of more than one function. So how to know? I have to apply composite derivative. See carefully, more than one function we have. Then how to differentiate? Very simple. Think, no, as if, no, you are going for, no, you are leaving one arrow there. Okay, and you should hit the target. So derivative you think as an arrow. When you are going to, no, aim on something and go for hit, no, your target is, it should, no, make sure that the target should go for each and every, whatever the things are there, no, combination, you should hit all the targets. Now see carefully. When I am leaving arrow here, target number one is f. So when I differentiate this with respect to x, that is obvious here, differentiate with respect to x. When I differentiate with respect to x, symbol will be the derivative. Now see carefully, target number one is f, so f dash, and whatever term is inside f should be retained as it is, because your target is first f, you have differentiated. Now this arrow will go still in. Who is the next target after f? G. So derivative of g is g dash. Simple. After g, nothing. Similarly, let us suppose that we have combination of three functions. Aram se you think. If you leave the arrow, target number one will be, so first let us write differentiate with respect to x. What will happen? Each and every term should be get differentiated. So when I am going to write derivative of y with respect to x, arrow, target number one, f will be, derivative will be f dash. Who is inside f? F inside is g and h. Correct? Now? After that, g is the second target. Derivative of g is g dash, and then keep the function inside g, that is h of x as it is. Then derivative of, after g, who's next? H. Derivative of h is h dash into derivative of x is what? 1. Derivative of x is what? 1. What I'm saying is, still if you go in, derivative of x is what? 1. 1 into anything is what? Same thing. So it means to say that you can also think this all simple function as combination of two function. What? For example, derivative of sin x is cos x. Again, derivative of x is what? 1. Again, what? 1. 1 into cos is what? Cos x only. And you can see in all this formula, as we are saying that similarly, okay, let's make this also. Derivative of cos x is minus sin x. After cos, next is x. Derivative of x is what? 1. Again, minus 1 minus sine x into 1 is minus sine x itself. So it's happening for each and every, I can think as combo of two functions. And here, one most important thing you see, observe carefully, whatever the angle is there here, same angle here, again see the same angle here, same angle here, see same angle here. What is the summary of the story? Summary of the story is, government says, save the trees. And here we are saying, save the angles. So whatever the angle is there, that should be preserved. And after that, see here also, arrow, you leave, first target is sine, it is cos, then it is angle x, differentiate. Okay. But when you differentiate, first the angle should be preserved. Remember this. So having this logic, let you take this point and let us try to generalize some of the formulas. Okay. Make it out first. Done? Now see carefully. For this, okay, since we have made a note, let I erase this. There itself, no, I want to quote the new formulas. See carefully. This is anyway not required. See carefully how we can frame the new formulas. Ready? See carefully, pay attention. Now, here I can have one generalized formula. Here I have got a particular function x. But let us suppose that I have got derivative of f of x whole power n, where f of x can be any function. It can be x, it can be trigonometric, it can be any other function also. But here the condition is base is a variable, power is a constant. Now if I leave my arrow, nothing but derivative I'll take as arrow. Who's target number 1? Bracket. Bracket is there because of whom? N. So base is a variable, power is a constant, so I have to apply this formula only. So see carefully. In place of x, what do we have? F of x. So write down n remains n. So n into, in place of x, f of x. So here f of x whole power n minus 1 I wrote. Don't forget, I have to differentiate each and every term. After bracket is done, I have to differentiate f. So derivative of f is f dash. Okay, that's it. Or for you to have a better understanding, you can also write derivative of f of x with respect to x. Similarly, you come to this derivative of root of any function. And actually, dear students, when I'm going to solve also, no, I am not going to say memorize this result. I'm just trying to make you understand how we are getting. If I have got some other function, for example, derivative of sine square. No need to memorize this result. You go with this only. Sir, here we have x. No problem. Compare. Base is a variable, power is a constant. Here also, base is a variable, power is a constant. Is it not? This is same as derivative of sine x whole power 2. Now compare. In place of base x, what do we have? Sine x. So this is working like x and this is your n. So apply here. N is 2. Then sine x whole power n minus 1. N is what? 2. So 2 minus 1. Clear? Okay. Then after sine miss bracket, who's the target? Sine, derivative of sine x. Now be careful. D by dx is an operator to differentiate. We don't have d by dx here, so you're just going to simplify this. We'll get 2 times of sine x whole power 2 minus 1 is what? 1 itself. So I'll get this. Derivative of sine x is what? Cos x. I have nowhere use this formula. Directly I got by using this logic. That's what I'm saying. Remember, whenever base is a variable, power is a constant, I apply this formula. Wherever x is there, it's a variable. Now, by using multiple angle formula, first POC, this is sine 2x. It's a standard result. Now, presently, till here coming is important. Their trigonometric formulas. Okay. Now come to this. Can you say no? Can you say this? See, same logic. Derivative of root x is 1 by 2 root x. Target amount is root when I give the arrow. So answer is 1 divided by 2 root of f of x. After root, next derivative of f. Derivative of f is f dash. Oh well, job done. For example, purposefully, I am trying to take an example on trigonometric function only. If I say find the derivative of root of tan x, very simple. First come to tan derivative. What is tan derivative? Secant square. Don't forget that. Now go one by one. Derivative is there. Who's the first target? As soon as you leave the arrow, oh, root. Now, root and under the root we have variable. Yeah, both are matching. Again, I'm not using this formula. Just from here. Okay? Root. Under the variable, under the root, we have variable. Here also, variable. Derivative of root x is 1 by 2 root x. So, whatever root x is there in numerator, that should go to denominator. Again, I repeat, whatever is there in numerator, root x, that should go to denominator. So, 1 divided by 2 root of tan x. Is that fine? Is this clear? Then derivative of tan we will write as it is. We have to find derivative of tan, the term inside the square root. This will be differentiated. Now see carefully, pay attention. So we have 1 divided by 2 root of tan x. What is tan derivative? Secant square. That's it. This is our first exercise, means 5.2 on composite derivative. Okay. First, I hope this logic is clear. First, kindly make a note. Okay. Okay. Dear students, having understood the composite derivative, let us try to build on that. For all this, whatever I have taken note is simple function. Let us suppose a combo of two functions, then how to evaluate. Okay. Now let us recall again. If I have derivative of f of g of x, so how many functions do we have? Two functions. So as soon I'm going to leave the arrow, that is derivative, target number 1 is f. So it will be f dash. Inside f, who's that? G of x. So keep as it is. Derivative of next, after the f, the arrow will move on to g. Derivative of g is what? G dash of x. Correct? No? That's what composite derivative. Composite derivative we are in. Okay? Composite derivative. We should know the names. What we are learning. See carefully now. In this regard, we also had a power x, right? So suppose that we have derivative of a power minus x. So it's a combo of two functions. One is a and having a minus x. In place of plus x, we have minus x. No problem. Recall what is derivative of a power x. It is a power x into log a into derivative of x is what? Derivative of x with respect to x, nothing but 1. That is nothing but 1. And base is e, that's understood. This is nothing but 1. 1 and anything is same. Now you see this also. Whatever is the same. See, compare the formula with this. To get this derivative, compare this formula, whatever is the same term. So I'll get a power minus x. Then log a. Now I should differentiate the power. That is derivative of minus x with respect to x. Minus into plus will be minus a power minus x log a. Derivative of x with respect to x is 1. That's it. So it means, for an example, if I ask you derivative of 7 power minus x, now I have to memorize this new formula. Logic is this formula only. So it is base is constant, power is variable. So apply this. Derivative is what? 7 power minus x into log base is 7. So 7. Correct? No? Base also is 7. Same thing. Then derivative of minus x. What is derivative of minus x is our next question. Minus into this plus will be minus. Then log 7 as it is. Derivative of x with respect to x is what? 1. 1 into this is same thing. Okay, minus is there here. Mind it. Okay. Now, dear students, let us proceed first with the algebra of derivatives. Let us suppose I got more than one function. How to differentiate? Okay, so algebra of derivatives. Let us suppose that I have got two functions, and both, if f of x and g of x are differentiable function. Differentiable function. Then, okay, first thing, let us suppose that these two functions, see, when I said algebra of function, what are the function we had? We had only one function. Let us suppose we have got more than one function. Then how to apply derivative for them? When I say more than one function, for function f and g to have, to come together, either there should be plus sign, minus sign, multiplication or division. So one by one, let us learn that. First one, sum rule. As the name suggests, between f and g, we should have addition. So derivative of f of x plus g of x with respect to x. So this rule, see, there is no bracket here, and we are not going to give any bracket. It's understood that till where this derivative is at, we are going to differentiate each and every term. So this will be derivative of f with respect to x plus derivative of g with respect to x. First part done. Second, difference rule. So in between the two functions, we have minus. So now how to go about this? Differentiate f separately with respect to x, then minus derivative of g of x. I hope this makes sense. It's clear. Third one, product rule. Nothing but in between the two functions, I have got multiplication. So see carefully. Derivative of f of x into g of x. In this, see which is the first function, second function. Bracket purposefully I have not mentioned. Is understood that till where the derivative, till whatever number of terms are there, derivative will be applied to each and every terms. So now here this is my first function and this is my second function as per the order. There is no hard and fast rule, no, that which one to choose first and second. Here it's left to you. Even if you take this as first function, this as second function, for product rule, no problem. You will get the same answer. So I usually take as first function, second function, then calling f and g. So keep the second function as it is, that is g. Differentiate the first function plus keep the first function as it is. Differentiate the second function. That's it. So keep the second function as it is, differentiate the first function, then keep the first function as it is, differentiate the second function. This we call product rule. And if you just want, you can take this also, u then v, and I want to differentiate, then use the first function, v is the second function. I repeat, use the first function, v is the second function. So keep v as it is, derivative of u is u dash, then plus keep u as it is, del of v is v dash. This we call Leibniz rule. Other name, just for your knowledge. Okay, no one's going to ask for an MC question on this. Okay, just for completion's sake. One more is scalar rule. What's the meaning of this scalar rule? Repeatedly we are going to use scalar rule. See, let us suppose that in place of your product, both are variable function. You can see x here. Everywhere you can see x. Nothing but these are not only function, variable function. Nothing but it's going to change. But let us suppose that we have got product of a constant k and f of x. K is a scalar constant function. So as to the order, k is the first function, f of x is second function. So when I apply product rule, keep the second function f as it is, differentiate k with respect to x, then plus keep k as it is, derivative of f of x. Now here you see carefully, what is derivative of k? I have said what k is what? K is scalar. Nothing but it is a constant. And we know what is derivative of a constant, 0. 0 into f of x is 0. 0 plus this will be same. So we are going to have derivative of k into f of x with respect to x is, what's remaining here? This is gone, 0 into anything is 0, 0 into any number is 0. K into derivative of f of x. This is nothing but scalar rule. Now, when to use this rule? Whenever you have got a product of a scalar and a variable function. For example, if I ask you derivative of 3 sin x, example, very simple. In 3 sin x, first is what? 3 constant, and this is what? Scalar. I repeat, 3 is a scalar, sin is a variable. Okay. Now I have to apply this rule. So this is my k, and f of x is, I repeat, f of x is sin x, k is 3. So just take out 3 out. Differentiation of sin x. What is derivative of sin x? Cos x. Then this 3 as it is. Over. Sir, if I apply product rule, are we going to get same answer? Let's take it. Let's take it. Or derivative of 3 into sin x with respect to x. So here, this recording, no. Yeah, always I'll have a doubt. Yes. Keep, as per the product rule, keep the second function as it is, differentiate the first function, plus keep the first function 3 as it is, find the derivative of second function. What is derivative of 3? 3 is a constant, so it will be 0. 0 into sin x is what? 0. Plus 3 as it is. What is sin derivative? Cos x. So finally, what's the answer? 3 times of cos x. So you can see whether this or this, both the answers are same. So when I can get the answer easily in one line, why should I go for more working? So in short, scalar rule is special case of product rule. And you can see I have got the result also of scalar rule, which is here, by using which concept? Product rule only. So when to use this? Whenever constant and a variable is multiplied, kick out the constant, differentiate the variable. That's what we can see here. But when to use product rule? If both the functions given to you are variable. Okay. Now let us take the last one, that is quotient rule. With that, algebra will be completed. So quotient rule. Now when to apply quotient rule? Coming to quotient rule, we should have division of two variable function. So derivative of f of x divided by g of x with respect to x. So here, who is numerator? F of x. Denominator? G of x. And what it says? It says square of the denominator. Keep the denominator as it is. Then differentiate the numerator. Minus, keep, I think it's not visible, right? Again. Derivative of f of x with respect to x. Minus, keep the numerator f of x as it is. Then derivative of the denominator, that is g of x. That is g of x. That's it. Okay. In short, we can also go for this. Write it here for this part. If I've got u divided by v, both u and v are variable function, then this does stand for differentiation. So same, in place of f it is u, in place of g it is v. So you can just write square of the denominator, keep the denominator as it is, derivative of u is u dash, minus, keep the numerator u as it is, then derivative of denominator, that is v dash. That's it. Okay. So having this logic, for this composite derivative when I take, we are going to use this rule repeatedly. First make a note of this. Okay. Make a note of this. Yeah, the other way of writing. Okay. Yes, dear students, having understood algebra of derivatives, let us move on to composite derivative. And here, whichever I'm going to take now, presently, we will be using the scalar rule, that is derivative of k into f of x is, take out the constant k out, differentiate the variable function. Scalar rule. Which rule? Scalar rule. Now see carefully one by one. Okay, we are in composite derivative. Okay, now see this. Now when I want to go ahead, what will, for all this will take composite derivative. So here if I take what are the numbering, 14, 15, 16, 17, okay, 14, 15, 16, 17, okay. Now derivative of e power ax, I want to find the derivative. Observe carefully, it's a combo of e and a power x, correct now? So always remember the parent formula, okay, the original. Then we can always go for the new one. See carefully, derivative of e power ax. So whatever is the same thing, correct now? So here also e power ax. After you write, now you should differentiate the power one by one. First e over, now ax. Now you see here, a is a constant. A is a constant. A is a constant. So I have to apply scalar rule, which is given here. Throughout all our problems I take now, a will be a constant. So scalar rule says, kick out the constant, differentiate the variable. A is a constant, remove out. Derivative of x with respect to x is 1. Derivative of x with respect to x is 1. Then 1 into a into 1 is a. So I can write a into e power ax. Job done. Now come here. If I give you 18th formula, derivative of log of ax. Okay. Let us have for all. Okay. Derivative of log is, see, carefully see. Derivative of log x is 1 by x. Here the base is e, mind it. If base is not e, how to differentiate? In further class we will learn. So whatever times is same thing denominator. Here derivative of log ax. Whatever is there here, that should go to denominator. So target number 1 was log, done. Now derivative of ax. So derivative of x, again by using this rule, a as it is, x will be what? 1. So a by a will get cancelled, get back 1 by x itself. Now come to this. What is derivative of sine ax? See carefully. Target number 1, who it is? Who is the target number 1? Sine. What is sine derivative? Cos. What's the angle here? Ax. Preserve the angle. Now derivative of ax. Keep a as it is. Derivative of x with respect to x is 1. So answer is cos ax. A into 1 is a. I will write this a. A into 1 is a. I will write this a left to the trigonometric function. Because if I write no here, many, if I write a here, like this, they may think of multiplying a and a square. Don't forget, cos a is single one term, okay? That's the reason always we prefer to write the constant when trigonometry is there, left to the trigonometry, okay? Next, formula number 20. Listen carefully this. This is the building, the base for the entire calculus. If this is clear now, just we can move on, okay? And whatever I'm doing presently, when I start integration, what is integration? Reverse process of differentiation. So again we'll recall this. So you have to be crystal clear, pay attention, and make sure you have to learn each and every formula with this logic, okay? Cos x. Now come on, I hope from here you are able to say yourself, at least after this 20th. Derivative of cos. Target number 1 is cos. What is cos derivative? Minus sine. What is the angle? AX. Now next target is this one, derivative of AX. So A as it is. Det of x is what? 1. How? By using scalar rule. Next, A into 1 is A. I can write left of trigonometry. So minus A, I repeat, minus A sine AX over. Now let's move on to this. 21. What is derivative of tan AX with respect to x? Tan derivative secant square x. So tan AX will be secant square AX. Derivative of AX will be A as it is, x will be 1. A into 1 is A, secant square AX. Now, just like this one, it got erased. Now move on to this one. See carefully. 12th, 22. Cosecant. I mean, it's a cosecant. Cosecant AX derivative. Derivative of cosecant x is cosecant x is minus cosecant x into cot x. Whatever angle is there, preserve the angle. Correct? No. So here also, whatever angle is there, AX, it should be preserved. So minus cosecant and cot. So cosecant angle is, what's the angle here? AX. So write down AX into cot AX. Now I have to differentiate AX. A as it is, x will be what? 1. A into 1, A. I can write left of trigonometric function. Cosecant AX into cot AX. Let us write down for secant. Okay, 22 over, so 23 here. What is derivative of secant AX? Derivative of secant AX. Now I hope we can write directly. See the formula, secant x into tan x. So plus secant, what's the angle? AX into tan AX, and derivative of AX, A as it is, x will be 1. 1 into A is A. I'm skipping this step. Directly I'm jumping from here to here, which is expected henceforth from you. Last one for cot. See here, derivative of cot x is minus cosecant square x. Okay, is already given. So now from here, see carefully, 24th one. Derivative of cot of AX with respect to x will be minus cosecant square, no? So minus cosecant square AX. X multiple is A. So apply usual scalar rule. A as it is, x will be 1. A into 1 is A. So with this, all the trigonometric function formulae as well as composite trigonometric formulae is completed. A can be any real number. Now you should understand one thing. See here, whatever the angle was there here, it is remaining same. Correct? See here. Right? See here also. Similarly, for this angle was AX, it's remaining same. So as I said, no. See here also AX. Yeah, here's for both AX. Here secant AX, angle is AX. Yeah, AX, AX. AX, again AX. Government says save the t's, and we say in differentiation save the angles. Okay. And one more thing before we go ahead. See all this from 19th formula till 24th formula. One thing we can analyze that under differentiation, when we have got this, you can see the scalar is also multiplied. This scalar is multiplied to the resultant. And whatever angle is there, the angle is same. Again, the angle is same. The scalar is A, it is there present again. Correct? No? For everyone, angle remain the same. Again, angle remain the same. Don't forget, preserve the angle. So one example we take. Derivative of, let us suppose, tan 5x. Very simple. Combo of how many function? 2. One is tan, other is 5x. Derivative of tan is what? Secant square x. So this will be secant square 5x. 5, preserve the angle. Then derivative of 5x. Keep 5 as it is. X will be 1 by using which rule? Scalar rule. 5 into 1 is 5. So answer is 5 times of secant square 5x. Job done. Make a note of this. We will take now inverse trigonometric functions, derivative formulas. Make a note. Okay, fine. Dear students, having finished trigonometric function derivatives formulae, now let us move on to inverse trigonometric function. So derivative of inverse trigonometric functions. In short, for inverse trigonometric functions, we call ITF. Now see carefully. This formula, and in one of the paper, no, I think 2 years back, they also asked no derivative of. I repeat, question was domain of derivative of sine inverse x. So not domain of sine inverse x. They are asking derivative domain of sine inverse x. Just see carefully. So I want derivative of sine inverse x. Okay, let's first try the formula. Derivative of sine inverse x is 1 divided by root of 1 minus x squared. Now they wanted the domain of this, not of this. For this one in ITF already we have discussed. Now for this, the domain of derivative of what? Inverse trigonometric function. Inverse trigonometric function. See carefully. For this, the domain will be -1 to 1 for this one. Okay, the derivative. That's why I give the heading here. So let us write the formula also, and you also have what? The domain for 1 marker. Next, derivative of cos inverse x. I don't remember numbering, so just I'm writing that. This will be -1 by root of 1 minus x squared. And the domain of this again is -1 to 1. Derivative of tan inverse x with respect to x is 1 by 1 plus x squared. Domain of this is all real numbers for this. Next, derivative of cot inverse x is -1 by 1 plus x squared. Again, the domain is all real number. Derivative of cosecant inverse x with respect to x is -1 by x into root of x square minus 1, where the domain of this is mod of x greater than 1 or x belongs to -infinity minus 1 union 1 to infinity. Open. Why open? If I take 1 or minus 1, 1 square is 1, 1 minus 1 is what? 1 minus 1 is what? 0. 1 by 0 is what? Undefined. Okay. Similarly, same case here. Put x is equal to 1. 1 square is 1. 1 minus 1 is what? 0. 1 by 0 is undefined. Okay. Similarly, derivative of secant inverse x with respect to x is 1 divided by x into root of x square minus 1, and again the domain is the same. You are going to memorize the formula and this domain part. If you just focus this one, no, with respect to ITF, the only change is there for sine inverse domain was closed interval -1 to 1 for these two, but now it is open interval because for derivative it is. Okay, here there is no change. Here also open interval. And see pattern here, plus minus, plus minus, plus minus. I think they are both are co-ratio. So as soon you know the derivative of this, for co-ratio minus. Again, see, for co-ratio minus. Secant inverse, secant co-ratio is secant. Again you see, same but minus. Same thing for sine cos also. It was plus minus, plus minus, plus minus. But result is not same. Okay, now only sign I'm talking about. So with this, all the formulas are done. Now we are just going to start with the problem. Now what I'm going to do is under this chapter, whatever exercise is there, for example, derivative of composite function 5.2 and 5.4 together I will take. all the problems from model question paper. I'll be going exercise wise. Nothing but concept and then that exercise. So concept is done. Now we will go for two exercise, 5.2 and 5.4 together. Okay, make a note of this. Dear students, I just saw in all the three model question paper, there are no problems on composite derivative. Doesn't mean that the concept is not important. Composite derivative is the base for all our problem which you are going to see. Okay. Now, but then what they have asked? See, they have gone for directly third exercise, that is on implicit derivative. First, let us understand what is explicit function and implicit function. Whenever we are able to write any function of this form, y equal to f of x, nothing but we have solved for y. This we call explicit function. For example, whichever the formula we wrote, all are what? Explicit. Okay, so for example, y is equal to sine inverse x plus 8. This is explicit. I am writing y in terms of x with a constant. Constant may or may not be there. This we call explicit function. Then what is implicit function? Implicit function. First understand this, then we'll take the problems. Coming to implicit function, any function which contains both x, y equated to constant, or I can also say that f of x comma y comma constant is equal to 0. It can be both the ways. It can happen that right hand side can be a non-zero constant or it can be a 0, and constant can be any of the side, no problem, but it should be a function of x, y together. For example, if I say x square plus y is equal to 0, this is also implicit, but we can convert some of the implicit to explicit. For example, transpose this, then y is equal to minus x square. Now this is explicit. This is implicit function, and where this is explicit. Now one question will come, is it possible for every function to convert from implicit to explicit? Need not be always. For example, you see this. Now you think of solving for y. If you solve for y, this y will go this side. Correct? Now see carefully. It can transpose. Then get 7 minus y. This y is transpose here. Take sine on both the sides. Then get xy is equal to sine of 7 minus y. Now take cross multiply x. So you get y is equal to sine of 7 minus y divided by x. This is not explicit. Why? Y is present in left also and the right hand side also. So every function need not be able to convert from implicit to explicit. Okay, this is one such. That's the reason we have got implicit derivative also. So this all problems are derivative of implicit function. Derivative of implicit function under this heading is the third exercise. So same thing I am taking, and as I said here, no, I can also convert what? Sum of the function from implicit to explicit. And one such problem is here. This is a 1 marker question. Again, the problem I am taking from KSEAB. Sorry, KSEAB word. And with this motive, we started our channel. So now, model question paper number 1, 2025 to 2026 academic year, 1 marker question. They are saying if x into y is equal to 81, then derivative of y with respect to x at x is equal to 9 is fill in the blanks question. So either I can apply product rule here, or I see this is actually implicit. I can convert to explicit. Y is equal to 81 divided by x. Now I should differentiate this with respect to x. Derivative of y is what? Dy by dx. Now here, can't we think as this 81 into 1 by x? Nothing but what? Scalar will have to apply. It's a product of scalar and a function. So 81 as it is, Derivative of 1 by x formula is minus 1 by x square. Differentiation completed. Let us continue here only. Now they want derivative value at x is equal to 9. So at x is equal to 9, our derivative of y with respect to x will be plus into minus minus. 81 into 1 is 81 divided by x value is 9, so 9 square. So minus 81 divided by 9 square is also 81. Both will get cancelled. Answer will be minus 1. Therefore, the value is minus 1. Okay. Now come to this. Now you see this one you cannot convert to explicit. You can try. You will get y is equal to sine inverse of cos x minus y. Okay. Now we want to find the derivative. Part B from model question paper number 2. Answer 2 marker. Very easy question. Now I'm going to differentiate this with respect to x, and I'm going to apply some rule because plus is there here. Algebra of derivative should be perfect. Derivative of y with respect to x is dy by dx plus some rule I'm applying. Let's go one by one. Some rule I am applying. So everywhere I am introducing the derivative, the symbol d by dx. And here derivative of cos x with respect to x. Here some rule I have applied. So there is no change here. Now see carefully. Combo of how many function? Two function. One is sine, the other is y. I repeat, sine and y. Derivative of sine x. Recall. What is derivative of sine x with respect to x? It is plus cos x. Whatever angle is the same angle here. Correct? Now then we should differentiate the angle. So see carefully. Here the angle is y. Derivative of sine y will be cos of y. Derivative of y is what? Dy by dx. Here derivative of x is what? 1. Because derivative of x with respect to x is what? 1 itself. But here it is y. Derivative of y with respect to x is dy by dx. So I have finished the differentiation of this. Now come here. Derivative of cos x is minus sin x. Now since in the question they want dy by dx, see, differentiation completed in one step. Now we have to solve for dy by dx. Now it's the school days. Since we want to solve for dy by dx, it's same like see this. If I give you one question, let's take it here. Something like this: x plus 9y is okay. X plus 9 x is equal to 7. So here you are going to take simplification. No, here if the like terms are there, we can add. Here like terms there we can add. Just see, I can just say that x is common. I'll get 1 plus 9, nothing but 10x is equal to 7, and cross multiply x is equal to 7 by 10. Correct? Now same way like that. Dy by dx is common. You can see common here. Then what is remaining? Multiple of dy by dx is 1 here, plus multiple of dy by dx is cos y here, is equal to minus sin x. Now product of two terms, same like this, cross multiply 10 here. So I'm cross multiplying 1 plus cos y. So I'll get derivative of y with respect to x is minus sin x whole divided by 1 plus cos y. That's it. Very easily you can obtain 2 marks. Okay. Now first let me make a note. I erase this content and then I will solve that problem. Make a note. Okay, dear students, let's take the last problem under this concept. We have to find derivative of y with respect to x if sin square x plus cos square y is equal to 1 from model question paper number 3 part B, and again it's a 2 marker question. Let us take the solution here. Let us take the data. So solution of this problem. Okay, so we have been given sin square x plus cos square y is equal to 1. Now that's what is, now see this, even though it is implicit derivative concept, I have to apply composite derivative. Correct? No? So when I differentiate this with respect to x. See carefully. Can't I see this problem? Okay, can't I see this? No, first target is sine. I'll do one thing. Before I differentiate, let us rewrite this to have a better clarity. Is it not the same as sine x whole power 2? Then cos y whole power 2. Now we'll get the feeling, no? Arrow. So for this I can use the formula. What is derivative of x power n? It is n into x power n minus 1 into derivative of the base. So see carefully. Without any difficult, n is 2. And x, this entire thing is what? Like x. Now when I differentiate this with respect to x, this will become n is 2. Then whatever x is the same x. So what's x here? Sin x whole power n minus 1. N is what? 2. So 2 minus 1 into derivative of the base. Correct? No? Whatever base is it, that derivative. So derivative of sin x. I hope this is clear. Again, let's repeat. If I compare, in place of x, it is sin x, n remains 2. N is 2. So n is 2. Correct? Then x, what is x? Sin x. Okay. Then n minus 1, 2 minus 1, derivative of the base. That's what in here, no? So base is sin x. Now come here. Again, if I compare with this, n is again what? 2, and this is acting like x. If I compare with the formula. So plus n is 2. Then x, what is x? Cos y whole power n minus 1. N is what? 2. 2 minus 1. Then derivative of the x, nothing but the base. Also base is cos y. So derivative of cos y with respect to x is equal to 1 is a constant. Derivative of a constant is 0. Don't forget the results. Results is important to memorize. Now around we can differentiate 2 as it is. Sin x. What is 2 minus 1? 1. Sin power 1 is what? Sin x only. Derivative of sin x is cos x plus 2 cos y. 2 minus 1 is what? 1. So cos y power 1 is cos y itself. What is derivative of cos y minus sin y? See carefully. It's a combo of two functions. One is cos, other is y. Derivative of cos y is minus sin y, and derivative of y is what? Dy by dx. You may ask, sir, what about derivative of x? You have not taken after sin x, the derivative is cos x. Why you have not taken derivative of x? Yeah, it is 1. No need to write because 1 into cos is cos only. Now here comes multiple angle formula. At least for this model paper, memorize this formula which I am going to quote. See, what is sine 2 theta? It is 2 sine theta into cos theta, right to left. Whatever the angle is it should be same, and into 2. So this angle will be double of this angle. Correct now? So you're going from right to left. So see carefully. This entire thing is exactly matching with this right hand side. In place of theta, we have got x and 2 as it is. Anywhere this 1 into cos x is cos x itself. So this will be sine 2x plus into minus is minus 2 sine y cos y. Goes with this only. In place of theta, we have y. So we'll get what? Plus into minus as it is sine 2y into dy by dx is equal to 0. Now simplify for dy by dx because they want in the question dy by dx. So product of, see, difference of two terms, so I can transpose. So we will get sine 2x is equal to sine 2y into derivative of y with respect to x. I is equal to 0, not there, sorry. Transpose, we'll get this, correct? Now find product of two terms. I want dy by dx, cross multiply. What we will get? Derivative of y with respect to x is sine 2x divided by sine 2y. That's it. We got the result. Okay, very simple. Yes, we have to learn the formulas. Without formulae, there is no calculus. Make a note of this. Okay, dear students, now let us move on to the next topic, that is derivative of inverse trigonometric functions. Formulas already have given on this. Okay, so now it is derivative of inverse trigonometric functions. Question number 23 from model question paper number 1. As we know, the academic year 2025 to 2026. Find derivative with respect to x if y is equal to sine inverse of 2x by 1 plus x square, where x is lying from -1 to +1 open interval. Now see, problems you are not going to differentiate directly. You are going to simplify. Now comes first PUC trigonometric formulas. At least, as I said, for whatever the question is there, at least for that you memorize the formula. See, here you have got sine inverse. As we discussed in inverse trigonometric functions, which I have already uploaded, since I have got sine inverse, I should generate here sine. And if you see carefully, this resembles one expression of the formula. It is 2 tan theta divided by 1 plus tan square theta, which is equal to sine 2 theta, multiple angle formula of first PUC. And as far as I said, left to right and right to left both should be perfect. So this is my equation number 1, and this I will take as equation number 2. So in place of x, it is tan theta. So put x is equal to tan theta. Let I give you a reason how I came to. I have to use this formula only. First, sine inverse is there. To remove sine inverse, I want sine here. In sine, we have two formulas for multiple angle formula. One is sine 2x or 2 theta. I repeat, sine 2 theta is equal to 2 sine theta into cos theta. Other is this. Okay. Now let us put this in equation number 1, and this even in integration also will be using. So sine inverse of 2 times of wherever x is there, it is tan theta. Substitute 2 tan theta divided by 1 plus tan square theta. Now, by using this formula, sine 2 theta, will get sine inverse of sine 2 theta. Yeah, both will get removed. 2 theta. How it is so? I'll discuss anyway. Sine will take what? Angle to, means domain to codomain, and sine inverse will take it back. Right now, from codomain to domain. Sine, and in detail I have discussed in ITF. That's complete. Now theta. Now what is theta? We have taken x is equal to tan theta. So I want only theta. So take tan inverse both the side. We'll get theta is equal to tan inverse x. Let us substitute in equation number 3. As soon as I put in equation number 3, we get y is equal to 2 times of theta, 2 times of tan inverse x. Now differentiate. Now just see, before I go ahead, see this expression and see the given question, which is simple to differentiate. This one or this one? This one, very simple. Only scalar rule I have to apply. Otherwise here, sine inverse derivative formula I have to apply, then I have to apply quotient rule, then simplify, and then get whatever we are going to get for this result. So it's better to use this method and remember the formula. So now when I differentiate this with respect to x, I will get derivative of y with respect to x. Apply scalar rule, 2 out, into derivative of tan inverse x I give as 1 divided by 1 plus x square. 2 into 1 is 2 divided by 1 plus x square. This is your final answer. And this is a 2-marker question. Okay. Now you see model question paper number 3. In 2 we don't have any question from ITF. Question number 6 for 1 marker. They are given if y is equal to sine inverse x plus sine inverse of root of 1 minus x square, x lying between 0 to 1, find the derivative. Options are given. See, if we see, this one is very simple to differentiate, but this one is looking bit complicated. Let us try to simplify this. See carefully. can't we take that second term, this term, sine inverse of root of 1 minus x square is equal to some angle theta. Okay, so if I take sine on both the side, we will get sine theta is equal to, I think Dan saying this all, no, let us go directly. Anyway, for one marker, working is not required. So let us not go for this. And let us reduce our working. Theta. Okay, theta. See, under inverse trigonometric function, what is there? The ratio of length. Logic is this. When sine theta is opposite by hypotenuse, theta will be sine inverse of opposite by hypotenuse by taking sine inverse both the sides. So always under inverse trigonometric function, we have got ratio of length. Now see carefully. Sir, you said ratio of length. There is no ratio of length. Only one number is there. And always I can say no, divide by 1. Now it's a ratio of length. So this is opposite, this is hypotenuse. Opposite for theta, this is the opposite side. So the opposite value is root of 1 minus x square. Hypotenuse is 1. I have to apply Pythagoras theorem to get what? BC value. So applying Pythagoras theorem, see carefully, AC square is equal to AB square plus BC square. What is AC value? 1. What is AB value? Root of 1 minus x square the whole square plus BC square. Now very clearly we can see that root and square will get cancelled. So remaining is 1 is equal to 1 minus x square plus BC square. 1 and plus 1 will get cancelled on either side. So after this, 0 is equal to minus x square plus BC square. Transpose this, BC square is equal to x square, or BC is equal to root of x square is mod x, but x is positive between 0 to 1. So I can just write x. So this length is x. Okay, this length is x. Let us complete here only. See carefully. So from here, whatever we have got, this one, no, sine inverse of what? Opposite by hypotenuse. So now I can say theta is equal to cos inverse of adjacent by hypotenuse. Adjacent is x by 1. So I will get cos inverse x. Okay, this entire thing we have assumed to be what? Theta, and cos inverse of, if we have assumed to be theta, and theta is what? Cos inverse of x. So if I put in equation number 1, we will get y is equal to sine inverse x plus cos inverse x. Now either you can differentiate from here, or you can use a formula, but the formula is not there. So let us try to, means in syllabus is not there. So let us not give one more formula for you. Let us differentiate from here only. Differentiate with respect to x. Derivative of y dash. Sine inverse derivative is what? 1 by root of 1 minus x square. Cos inverse x derivative is what? Minus 1 by root of 1 minus x square. Both terms are same, but signs are opposite. So both will get cancel. Yes. And you will get the derivative to be what? 0. So option C is correct. So option C is correct for question number 6. Make a note of this. Dear students, just now we have completed this problem, but it was a bit lengthy. Since it's a MCQ question, we can think of a short trick. Now let us try to solve the same problem by a short trick there. See, we have one formula saying that sine inverse x plus sine inverse of y is equal to pi by 2, provided the sum of the square of these two terms is equal to 1. Okay, if this condition satisfies. Now let us check. See carefully. X and y, in place of that we have got this. Let us see sum of the square. X square plus root of 1 minus x square the whole square. Root and square will get cancelled. There is no question about mod here because x is defined such a way that it is always positive. Okay, so what you will get? x square plus 1 minus x square, both will get cancelled. Yes, I got 1. So it is obeying this condition. Therefore, this value will be equal to pi by 2 as we have given here. What is pi by 2? 90 degree. And what is 90 degree? A constant. And what is derivative of a constant? It is 0. So we have no way to use any formula of derivative of this, and we have got answer directly. So option C is correct. And this is the beginning for CET. Okay, make a note. Dear students, having discussed implicit derivative followed by inverse trigonometric derivative, now let us move on to the next concept, logarithmic differentiation. Now, what is and why do we need logarithmic differentiation? Let us try to understand this first. Logarithmic differentiation. Before we take up the problem on this, let us try to understand some of the properties of this. Before I go ahead, see if I have got log A okay. So let us try to understand some of the basic terminology about logarithm. So here log A to the base B, let us say, is equal to m. Here B is called base of the log, and always the base is positive and it is not equal to 1, the definition. Then A is always a positive real number, and m can be any real number. M can be any real number. The output can be any, the output of this is m, it can be any real number. Now on this we have got some properties which we'll be using. Now what are those properties? First property, log m into n to any base. Okay, B have taken, so I'll take B itself, is same as log m plus log n to the base B. Second property, log m by n to the base B is same as log m minus log n to the base B. Third one, log m power k to the base B. So you can see the power k is here. So we can take this power k, it can come here, left of the log. So it is k into log m to the base B. And we have one more, we call change of base. Change of base. So here suppose we are not happy with the base B, so we can always change the base to some other base. But when I say some other base, satisfying this condition, okay? So it can happen that log A, I can have some other base D divided by log B and the base D. You can see the base B became a number here, logarithmic number, and base we can take whichever we want, but both should be same. And this will be very useful whenever we think of finding the derivative of log, but the base is other than e. Okay. Next is a power log of f of x to the base a. So you see this, the entire expression base is a, and the log base is also a. Whenever the bases are same, then the value will be only f of x. Surely when f of x is positive. Okay, because f of x is contained inside the log, and any term which is inside the log should be always what? Positive. Okay, so these are the result. And one more thing I want to highlight here about log, coming to the base. If base is 10, we call it as common logarithm. And see, this common logarithm where the base is 10, you are using in class table of your now when you are having experiment in physics classes. Okay, class table you use where you are going to find log and anti-log. There the base is taken as 10. Okay, and if this is the first point, second point, if the base is e, in place of base b it is e, the exponential number e, then it will be natural logarithm. That will be natural or Napier logarithm. Okay, so having all this basic, let us move on to logarithmic differentiation. Now coming to logarithmic differentiation, why do we need first? Let's try to understand. First I will take x power n. Can we get the derivative of x power n by using log concept, and whether the result will remain same as the first principle? Let's try to check. So I'm taking the first problem, y is equal to x power n. So now let us take log on both the sides. Okay, so take log on both the sides, then we'll have log y is equal to log x power n. Now for this I can always use third property where k is coming left of the log. So here in place of k we have n, it will be left of the log now. So n into log x is equal to log y. Since you want derivative, differentiate this with respect to what? X. Derivative of log y is what? 1 by y into dy by dx. Derivative of y with respect to x. Here, don't forget n is any real number. It's a constant. It's a constant. So when I want to differentiate, now I have to apply scalar rule. N is a constant, so n as it is. Derivative of log is what? 1 by x into here. If I put a better dot, don't think as x. Now I want dy by dx, so cross multiply. So we get the derivative of y with respect to x is n into y into 1 will be y divided by x. But what is y from equation number 1? It is n as it is. Y is what? X power n divided by x. By using law of exponents, I can write n into x power n minus 1. Here 1 it is, it goes up, and therefore derivative of what is y? X power n. Derivative of x power n with respect to x is n into x power n minus 1. See carefully, we have got the same result what we know, the standard one, which I gave as the first formula. Now what I want to comment from here is, whichever the result we already know, if I use log concept we will get the same answer. There won't be any deviation. That is my attempt for you to understand from this problem. Now the question is, when we have got already this, why do we need logarithmic differentiation? See carefully, here base is a variable, power is a constant. So whenever base is a variable, power is a constant, I can use this formula directly. Similarly, if I have got derivative of a power x, why do we need this? Whenever base is a constant, power is a variable, then I can use this formula. But now the problem is, the real problem for us is, see this question. Anyway, x will be positive. Both base and powers are variable. To apply this formula, base should be variable, power should be a constant. To apply this formula, base should be a constant, power should be a variable. But here, both are variable. So I cannot apply now this formula, nor this. Now comes logarithmic differentiation. So whenever both base and powers are variable, there is no other way than logarithmic differentiation. Sir, how come? What is the benefit? Now just see carefully. First, I will take log on both the sides. When I take log on both the sides, I will get log y here is equal to log x power x. Now this, by using third property, again, in place of k, we have this x. So this x which is present here, by using the property number 3 of log, this x will be left of log. So we are going to have log y, yes, is equal to x into log x. Now I have to apply product rule. Now see, before I go ahead, see, we had a problem in differentiating here was base and powers are variable. As soon as I apply the log on both the side, you can see the problem which we had, that both base and powers are variable. As soon as I apply log by using this property, now it's become a product. Nothing but surely I'm going to apply product rule. Now there is no problem of base and power to be variable. Now in this is my one entire function, and it's my first function, this is my second function. So when I differentiate this with respect to x, derivative of log y is 1 by y into derivative of y with respect to x. Now, as per the product rule, I can just say x is my first function and the log x is second function. So keep the second function log x as it is. Derivative of x is what? 1, plus keep x as it is. Derivative of log x is what? 1 by x. So very clearly you can see that x by x will get cancelled, and cross multiply this, we get derivative of y with respect to x is equal to y times of log x into 1 is log x plus 1 into 1 is 1. But what is y from equation number 1? X power x. So derivative of x power x divide with respect to x, I mean to say, is x power x into a plus b same as b plus a. I can just as 1 plus log x. A very important result also. I would prefer you to memorize this result. Derivative of x power x is x power x into 1 plus log x. So you can see here, whenever we have got base and powers to be a variable, always we can apply logarithmic differentiation. And not only that, if you have got complicated expression, then also we can go ahead. Now here I would like to take one problem here where you can see the benefit of this particular property. Now here I have not mentioned the base. Whenever base is not mentioned, it is always a Napier, nothing but natural logarithm. Even our derivative of log x with respect to x, which is 1 by x, is taken into consideration by assuming the base is e, nothing but Napier or natural logarithm. Now let us suppose that we have got a question. I have to find if y is equal to log x to the base 7, and I have to find derivative of this. Now see carefully, base is what? 7. So I cannot apply derivative of log x with respect to x formula because there the base is e. So now this I can use this change of base. See carefully, in place of a x is this, in place of b 7. So I can use this concept. So I can write this as log x divided by log e, divided by log 7, and I am free to choose whichever base I want. Now since I have got log here, I can take the base to be what? Since I want to differentiate, I am taking what? The base to be e here. Okay, now I want to differentiate this. Okay, but this don't need to apply quotient rule. Reason is denominator is a constant, so I can apply scalar rule. It is 1 divided by log 7. So I take out 1 by log 7 out. Then I have to differentiate only log x to the base e. Derivative of log x to the base e is 1 by x. And this log 7, 1 by log 7 as it is. I repeat, 1 by log 7 as it is. That's it. So the benefit of this is whenever the base is other than e, we can always apply change of base rule and we can differentiate easily. Okay, so now we can start with the problem from the model question paper. Make a note of this. Okay, dear students, let us move on to the problem on logarithmic differentiation from model question paper number 1. As we know, the academic year is the same, 2025 to 2026. Question says, if for some fixed positive a and x positive, y is equal to a power x plus x power a plus a power a, then find derivative of y with respect to x. Here, there is no way we are going to use logarithmic differentiation, but after I solve, I want to just give one question where you will see that for that particular question, after I solve this, how we are going to tackle with respect to this concept. Now let's first find I want to find the derivative of this. So if I differentiate this, derivative of y with respect to x is a power x. Derivative formula is a power x into log a. Base e did not be written, it's understood. Now here, base is a variable, power is a constant, so I have to use x power n derivative. So I'll get, in place of n we have a, so it will be a into x power a minus 1. Then here both base a and power a, both are what? Constant. Other than x and y, presently in our concept all are constant. So a power a, since base is also constant, power is also constant, derivative of this is what? 0. This is something like this. Derivative of 10 power 10, both are constant. So the answer will be what? 0. So now simplify. A power x log a plus a x power a minus 1. Let us see which option is matching. Yes, it's matching with option C. A power x log a, yeah, x power a into x power a minus a. So option C is correct. A very simple one marker question. Now why I took this one in this regard is, let us suppose the same problem. We have got y is equal to a power x plus x power a plus a power a plus x power x. Find the derivative now. So this term contains both base and power to be variable. So for the last term without log we cannot differentiate. But as I said, to memorize the result, so as soon as I differentiate this with respect to x, this is the additional problem from my end, Q. Derivative of a power x is a power x log a, just now I explained. Then this will be a into x power a minus 1. A power is a constant 0. And for this I have just said, derive the result. Derivative of x power x is x power x into 1 plus log x. Okay, that will be the answer. Kindly make a note of the same. Yeah, dear student, we have one. Okay, dear students, we have one more question for 3 marks because it's question number 33. So it's obvious 3 marker question. Question says differentiate y is equal to sin x power x plus sin inverse x with respect to x. As you can see, they will not mention the method name. You are the one who should identify. There is no problem with this, but here we have a problem, but that both base and power are variable. So surely I have to apply logarithmic differentiation. But see carefully, when I'm taking the question directly, you cannot apply a log on both the sides. Reason: log of m plus n is not equal to log m plus log n. Don't think it's a product of 2 terms that you can multiply. It is same like sine of x plus y is nowhere equal to, you cannot multiply sine in, correct? No, it's a sine of angle x plus y. Similarly, log of the number m plus n it is. So having this logic, they are not same. Then how to tackle? For that, see carefully. I'll take this as equation number 1. We have a table with this, so take this one separately. Let u is equal to sine x power x. As I said, presently the variable are only x and y, in which x is independent variable and y is a dependent variable. Now since x care is taken care, x care is taken care by u, now u is also a dependent variable. Okay, so now base and power are variable, so I will take log on both the side. Take log on both the sides. Before we proceed, before I proceed, see carefully. If I substitute this one back here, okay, let I just do this. Let I just first do this. And here v is what? Sine inverse x. So okay, this is our same thing I copied here. So this is my equation number 2. This is our equation number 3. So if I substitute both equation number 2 and 3 back in 1, our equation number 1 will be y is equal to, this one is nothing but u and this one is nothing but v. So if at all I want to find the derivative with respect to x, we are going to have derivative of y with respect to x is equal to, now since u is taking care of x, here also v is taking care of x, both u and v are dependent variable. Same like derivative of y with respect to x is dy by dx. So derivative of u with respect to x will be du by dx plus dv by dx. So this is our equation number 4. Mean to say, find the derivative of u with respect to x and then v with respect to x. Then you are going to substitute here. Here we are going to substitute. So let us go ahead one by one. See carefully, pay attention. So u is equal to, what do we have? Sin x power x. Now let us take log on both the sides. Take log on both the sides, log. Now log u is equal to log sin x power x. Both, sorry, x properly. Both base and powers are variable. So again, using this property, so I can rewrite this one as this x will be here. So I'll get x into log of sin x. So this is one single term and this is the other term. So very clearly we can see that log x is the first term and log of sin x is the second term. So now I'm going to differentiate this with respect to x. Log u, let us write down as it is. Find the derivative, differentiate with respect to x. Log u derivative is 1 by u into du by dx. Same like log y will be what? 1 by y. Combo of two functions, no? First is log x. What is log x derivative? 1 by x. So it is 1 by u because u is present. Then derivative of u with respect to x is du by dx. Now applying product rule, keep the second function, that is log of sin x, as it is. Algebra of derivative, product rule here. Derivative of x is what? 1 plus, keep x as it is. Derivative of log sin x, combo of two functions. First is log, then it is sin x. Let us try to write and explain you here. What is derivative of log x? With respect to x, it is 1 by x into derivative of this x. Into derivative of x with respect to x, correct? No? So derivative of log sin x is 1 by sin x into derivative of this sin x. Now, since I want du by dx to substitute here, let us solve for du by dx. Product of two terms, I can cross multiply. So we are going to have derivative of u with respect to x is u into log sin x into 1 will be log sin x plus x by sin x. What is derivative of sin x? Cos x. Now derivative of u with respect to x is equal to u. From equation number 2, which we have taken here, same, I will give the same numbering. So equation number 2, what is u? In place of this u, sin x power x, I can substitute here. Then log of sin x plus x. What is cos by sin? Cot x. Okay. Yes, we have found this. So let us say this is equation number 5. Don't forget, I also want dv by, means derivative of v with respect to x. What is v? We have v, we have assumed this, and it's a very simple function. So here no need to take log for this. So if I differentiate this with respect to x, derivative of this is derivative of v with respect to x is equal to sin inverse will be 1 divided by square root of 1 minus x square. This is our equation number 6. Now we are ready with the final answer. Don't forget, derivative of y with respect to x is our final answer. So put equation number 5, that is this, and equation number 6, both we can put in equation number 4. So put equation number 5 and 6 back in equation number 4. So derivative of y with respect to x is du by dx is present here. Substitute this sine x whole power x into log of sine x plus x into cot x. Okay, then let's close the bracket. Then what next? Du plus du by dv by dx. So plus dv by dx is here. So plus 1 by root of, let's erase this, root of 1 minus x square. So this is our final answer. So the marks distribution can be like this: finding du by dx 1 mark, dv by dx 1 mark, and final answer. Okay, so make sure, kindly make a note. You should also understand, since base and powers are variable, only for that term we have taken log concept, but here there is no such problem, so directly we can evaluate. Okay, make a note of this. Okay, dear students, let us move on to model question paper number 2. Let I check once. Is it 2 only? Yeah, it is model question paper number 2. Question number 6, as you know, it's a 1 marker question. Question says the derivative of e power log x to the base e with respect to x is. Coming to the solution of this, you see this term. First, let us equate to y, explicit function it is. Now, see the base of this entire expression e and see the base of the log e. Both are same, nothing but this property, that whenever the bases are same, whatever term is there here, that is our answer. So here, the term in place of f of x, we have x. So it is y is equal to x. Now I want to find the derivative. Differentiate with respect to x. What is the derivative of x with respect to x? 1. That's it. Option C is correct. A very simple question. If I remember this property, only then I can dominate. Now come to this. 16, again a 1 marker question. We have to differentiate 3 into x power x with respect to x at x is equal to 1. Fill in the blanks question. Here if you see 3 is a constant, x power x is a variable. By using scalar rule, 3 I can take out. Derivative of x with respect to, derivative of x power x with respect to x, I have to find. What is derivative of x power x? It is x power x into 1 plus log x. Now at x equal to 1 we have to evaluate. So at x is equal to 1 we have 3, then 1 power 1, then 1 plus log 1. What is log 1 value? Recall, log 1 to any base a is always 0. You can include as a property number 6. Okay, here we can include. So log 1 is 0. Then 1 plus 0 is 1. 1 into 1 will be 1. 1 into 3 will be 3. Therefore, the answer for this fill in the blanks is 3. Okay, a very simple problem they have given. Make a note of this. Dear student, before I forget, let's not forget that 12 plus marks is assured from this. Now, coming to model question paper number 3, we don't have any question from logarithmic differentiation. So that's the end for logarithmic differentiation. Now we are going to go for parametric derivative. Okay, parametric differentiation. Now let us understand what is this and how to recognize from the question that I have to apply this concept only. So far we had explicit and implicit. Coming to explicit and implicit, we had only one independent variable x and y dependent variable, and both are interrelated. For example, explicit was this y equal to f of x. So y is directly depending on x. Whereas in parametric what's happening is both x and y are not interrelated with each other. There is some other parameter for which both x and y are depending. I mean to say, x is some function of t and y is also some function of t. So here t is parameter, independent variable, and it's a parameter here. Parameter. And t is also independent variable here. So the role of x is taken care by t. Okay. Now you can see both x and y are not interrelated with each other, but they are indirectly related with each other with the parameter t. Okay, and one more thing, in place of t, it can also happen, it can be some other variable theta. Okay, no problem. So either I have to discuss the concept with respect to t or theta. Let us suppose we take with respect to t. Now what we are going to do is, we are just going to, now see, since if y is a function of x and x is independent variable, so we are going to differentiate y with respect to x. And same thing, I got f dash of x. Here, since t is the independent variable, we are going to differentiate with respect to t. So we will get, now see, the way y is dependent variable, for which d by dx is the operator applied, here also d by dt is the operator to be applied on x. So x is dependent variable now. So dx by dt is equal to f dash of t. Let us suppose that we are going to take this, then differentiate with respect to theta. So here it will be theta and here also theta. Similarly, come here. Again for this only, if I differentiate, that is y equal to g of t, differentiate with respect to t, then derivative of y with respect to t is equal to g dash of t. But since we want ultimately derivative of y with respect to x, derivative of y with respect to x, it will be derivative of y with respect to t divided by derivative of x with respect to t. Just we are going to divide that, where derivative of x with respect to t should not be equal to 0. If this is 0 and this is non-zero, I'll get infinity, nothing but I'll get a vertical tangent. Okay, don't forget, we already discussed that if y equal to f of x represents a curve, the first derivative stands for slope of the tangent. So if dy by dx is undefined, we'll get a vertical tangent. Okay, kindly make a note. Okay, dear students, we have only one question, and this is from model question paper number 2, 3-marker question. Question says, cross check, is it model paper number 2? Yeah, it is model question paper number 2. Find the derivative of y with respect to x. If you can see how to know its parametric, see carefully, we will have two equations. X will depend on some other variable, y on some other variable. So it can be t or theta, some other parameter. Okay. Now I want to find derivative of y with respect to x. Now let us proceed. So x is depending on theta. So differentiate this with respect to theta. Derivative of x with respect to theta is dx by d theta here. A is a constant. So I have to apply scalar rule, take out a. Now I should differentiate. Derivative of theta with respect to theta is 1. Same like derivative of x with respect to x is what? 1. What is derivative of sine theta? Cos theta. Now again here also, differentiate this with respect to theta. So derivative of y with respect to theta is equal to, again scalar rule here, a as it is. Now difference will have to apply. Here we apply some rule. Now here it is difference rule, which says differentiate term by term. Derivative of 1 is a constant, so 0, minus derivative of sine theta. I repeat, derivative of cos theta is minus sine theta. Minus plus So I'll get A sine theta. Now I will take this as equation number 1 and this as equation number 2. Don't forget this is derivative of y with respect to theta. We want dy by derivative of y with respect to x. What is the formula for this? See carefully. The formula for this is derivative of, since numerator contains y, derivative of y with respect to theta divided by derivative of x with respect to theta, where derivative of x with respect to theta should not be equal to 0. Now be careful, hurry, what happens now? Even though the formula you would correct, but in hurry you will substitute this one in numerator and this one in the denominator. Completely reverse. Be careful. Since y is in numerator, so derivative of y with respect to the parameter, then derivative of x with respect to the parameter t. So dy by d theta is here, a sine theta. Derivative of x with respect to theta is a times of 1 plus cos theta. Now from this, it is from equation number 1 and 2, we have a by a will get cancelled. Simplify it. What is 1 plus cos theta? I have given the formula in inverse trigonometric chapter. This is 2 times of cos square theta by 2. And what is sin theta? Submultiple angle formula. Sin theta is 2 times of sin theta by 2 cos theta by 2. This is theta. So here you are going to have 2 times of sin theta by 2 into cos theta by 2. And again, what is 1 plus cos theta? It is 2 times of cos square theta by 2. Now some of the terms will get cancelled. See carefully, 2 gone. 1 cosine gone here. So I am going to have written with sin theta by 2 divided by cos theta by 2. What is sin by cos? Tan theta by 2. That's it. A 3-marker show means 3-marker question if it is asked. Okay. Actually, the good thing about the model papers, all the 3, they have given problems such a way that on each and every concept of differentiation we have a problem. That's very good. Okay, make a note of this. Yes, dear students, having completed this problem, just let me comment one more thing here, that which is obvious, okay, which is obvious. What is derivative of y with respect to t? It is g dash of t, okay, let's write that also, comma, divided by, what is derivative of x with respect to t? It is f dash of t, okay. Now nothing else, just I thought I will even substitute, okay, fine. With this parametric differentiation completed, kindly make a note. Okay, dear students, having completed parametric differentiation, now the last concept, that is successive differentiation. Let us move on to the next concept, successive differentiation. On this, we are going to surely have a 5-marker question also. First, let us take the concept, okay. Let us suppose that we have been given a function y equal to f of x. Now, as we know that when we differentiate this with respect to x for the first time, the operator d by dx stands for I am differentiating with respect to x. What represent here? Nothing but y. And don't forget y is what? Let's recall. What is y? Y is same as f of x. What is this? Dependent variable. Dependent variable. At the starting of the class we discussed this. Let's recall again. And what is x? Independent variable. Independent variable. Now we are always differentiating with respect to independent variable x here. So this operator is taken on both the sides to differentiate, which stands for differentiation. So derivative of f of x with respect to x. Now the other symbol for this will be y dash, and for this it will be f dash. Okay. Now when I say successive differentiation, next again I want to differentiate. So again differentiate with respect to x. Now when I say again differentiate with respect to x, surely I am going to differentiate the step before this, nothing but the first derivative. So you have to understand and remember this we call first order. First order means I have differentiated only once for the first time. When I again differentiate, see carefully, this symbol of derivative is imposed on all this. So when I impose on this, see carefully. Similarly here also, I am imposing dy dx on this term. We should understand the notation, dear students. But writing like this is a time consuming. So this, see, this is already first derivative. On that again I am differentiating, nothing but this is second derivative. So this will be the notation for second derivative. Square is on d and here x square. Okay. Similarly here also. Okay. So whenever you see any expression like this, it's a second order derivative. So this is first order derivative. And other way of writing this is y subscript 2, nothing but I am differentiated twice. Or it can be y with double prime, nothing but differentiated twice. Similar, it can be here only one prime, derivative only once. And here also same thing, f double dash. Actually, okay, first this we call second order derivative. We have differentiated twice. Second order derivative. See, one thing from here you should also understand. No, as soon they say find the second order derivative, there should not be any confusion that when this is the question given to you and you want to find second derivative, surely first you should find first derivative. Again differentiate the first derivative to get the second derivative. I repeat, again differentiate the first derivative to get the second derivative. Logic is very simple, dear student. If you are in ground floor, and you want to go to second floor, okay, okay, surely while crossing, or I can say while going from ground floor to second floor, you have to cross first floor. Some might say, sir, I will use lift. You will use lift, staircase. Even you take some other medium also. When you are in ground floor, to go to second floor, you have to cross what? First floor. Similarly, from the given question, to find the second order derivative, surely you have to differentiate for the first time. I hope this point is clear. And in general, let us suppose we want nth derivative. Then the symbol D, capital D and N here. This stands for nth derivative, which we are not going to discuss. Okay, in PUC. Only till second order derivative. Okay. And here, first order derivative with respect to what? X. This is second order derivative with respect to what? X. Let us mention that also. That it is first order derivative with respect to x. Then second order derivative with respect to x is understood, but let us just quote that. Okay. So kindly make a note of this. Okay. Dear students, having understood the concept, let us move on to the 5-marker question. See, here you will be seeing at a time composite function, inverse trigonometric function. So make sure before going to this, all the previous concept which has been discussed in this present video, you should be the perfect along with the formula. No compromise with the formula. Okay, no compromise with the formula. Okay, be careful. So model question paper number 1 from KSEAB of this academic year, part D. Question for 5 marks. It says if y is equal to 3 times of e power 2x plus 2 times of e power 3x, nothing but explicit function, then prove that second derivative minus 5 times of first derivative plus 6y is equal to 0. Let us go ahead with this solution. See, In the question, you can see I want second derivative as well as first derivative. Let us suppose that in the problem this was not given and they gave only this. As I said, from ground floor to reach to second floor, surely you have to cross first floor. So if y is given to you and let us suppose this is not given, only you want second derivative, then also you have to differentiate twice, correct? Because when you differentiate first derivative, only then you get what? The second derivative. Okay, I hope this point is clear. So now it is differentiate this with respect to x. Now the symbol derivative of y with respect to x is equal to, here we have plus, so sum rule, and here you see it's a multiplication of a constant and a variable. So recall, just write it here, recall derivative of a constant into a function scalar rule. We can take constant out and differentiate what? Variable function, that is f. So here in place of k we have 3, in place of f we have e power 2x, so 3 out. What is derivative of e power 2x? For this, recall what will be derivative of e power mx with respect to x. For this, what is derivative of e power x? E power x itself, nothing but the same function, same power, whatever is there here. Then derivative of this, apply scalar rule, m as it is, x will be what? 1. So the final answer will be m into 1 is m e power mx. So derivative of e power mx is m into e power mx. So either you can remember the logic or the formula left to you. So in place of m, what do we have? 2. So we are going to have into derivative of e power mx is m into e power mx. So derivative of e power 2x is 2 into e power 2x plus this 2 as it is, again into, because product of two function, so scalar, again scalar rule, derivative of e power 3x is 3 into e power 3x. If you compare with this formula, in place of m we have 3. Now simplify. So in place of writing like this, I can also write first derivative. Okay, 3 into 2, 6 e power 2x. Then 2 into 3, again plus 6 e power 3x. This is our first derivative. I also want second derivative. So again, differentiate with respect to x. So we are going to have the second derivative. It's not that you have to give the same notation. This all allowed. Okay. Now 6 times of, again here press this, so sum rule. For this I have to apply scalar rule. So 6 as it is as per this concept. So in place of k we have 6. In place of f of x we have got this e power 2x. This entire expression is your f and this is your scalar k. So derivative of e power 2x will be same this logic. In place of this m we have 2. So 2 into e power 2x. So into 2 into e power 2x plus 6 as it is. Again scalar rule. Again in place of this m we have 3. So derivative of e power 3x is 3 into e power 3x. So second derivative is equal to 6 2s are 12 e power 2x plus 6 3s are 18 e power 3x. So now let us take the left hand side of this, substitute, and after simplification you should get 0. And you can see second derivative, first derivative and y is involved. So I will take the given question as 1. Then whatever the first derivative we got, it is equation number 2. Let us highlight here. And this is our equation number 3. So let us consider left hand side. What is that? Second derivative minus 5 times of first derivative plus 6 times of y. What is second derivative? It is there here. 12 times of e power 2x. Then plus 18 times of e power 3x. Then minus 5 times of derivative of y with respect to x. That is there in equation number 2, second derivative. So 6 times of e power 2x. See, it's a product. So many students, what they will do, just see 6 into e power 2x, just they will put a cross mark, e power 2x, then plus 6 into e power 3x. See the error. If you are just putting a cross mark or a dot, it means 5 is only multiplied to the first term, not for the second term. But see here, this 5 should be multiplied to the entire first derivative, which is nothing but this entire expression. So, in place of giving a multiplication sign, you have to give a bracket which says that minus 5 should multiply to both. Okay, plus 6 times of y. What is y? Given question, 3 into e power 2x plus 2 into e power 3x. So 3 into e power 2x plus 2 into e power 3x. How I got all this? From equation number 1, 2 and 3. We have given the reason. Now to simplify. There is nothing to simplify for the first two term. Retain as it is. Then minus into plus will be minus. 5 into 6 will be 30 e power 2x. Minus into plus is minus. 5 into 6 will be again 30 e power 3x. Then 6 into 3 will be 18. So plus 18 e power 2x. Plus into plus will be plus. 6 into 2 will be 12 e power 3x. Sorry. Yeah, now it is simplified. Now see which are the term. We have got only two terms actually. One is e power 3x, other is e power 2x. So let us try to write down their multiples. First for e power 2x. Simultaneously, let us write the term for e power 3x. Now, e power 2x multiple is plus 12. So e power 2 is already out. So only plus 12 will be there here. This is done. Next, e power 3x multiple is plus 18. Yeah, e power 3 is here. So plus 18. This also done. E power 2x multiple is minus 30. E power 2x multiple is minus 30. This also done. E power 3x multiple is minus 30. Okay, write down. This also done. E power 2x multiple is 18. Yeah, e power 2x multiple is plus 18. Then e power 3x multiple is plus 12. Yeah, write down plus 12. Show all the steps. Now simplify. How much is 12 plus 18? 30 it is. Minus 30 e power 2x plus again 18 plus 12 will be how much? 30 minus 30 as it is e power 3x. Is it not? Plus 30 and minus 30 both will get what? Cancel. So I'll get this entire will be 0. So 0 I'll get. 0 into e power 2x is what? 0. Again first also I'll get 0. 0 into e power 3 is what? 0. And I got place it as it is. 0 plus 0 is what? 0. That's what they wanted. Yes, we got the right hand side. Show this working. Let the evaluator be happy. See, when you are going to be so clinical, no. It means for them, yes, you know the subject very well. Okay? Yeah, kindly make a note. Okay. Dear students, on the last problem, this will be the assignment. There we had numbers. Here we have got alphabets. Okay, same procedure. You will get the answer. Okay. Now coming to the next model question paper number 2. Okay. Again, 5-marker question. If y is equal to sine inverse of x is given, then prove that 1 minus x square into second derivative minus x into first derivative is equal to 0. We have to prove this. Now again, differentiate with respect to x and we know the formula. What is derivative of sine inverse x? 1 divided by root of 1 minus x square. Now before you differentiate for the second time here, because you have a second derivative, always for all the 5-marker avoid quotient rule. Which rule? Quotient rule. Recall when to use quotient rule? If you have denominator to be a variable. So we will cross multiply to avoid quotient rule. Now one question will be there, sir. What if I apply quotient rule? Nothing wrong, but your problem will be a bit lengthy. Okay, but if you avoid quotient rule, in no time you can get the answer. Okay, so first derivative into root of 1 minus x square is equal to 1. Now I have to differentiate this entire expression. So again, differentiate this with respect to x, and I have to apply visually a product rule because product of two variable. Y dash, the first derivative is also a variable and it's a dependent variable. Okay. So now when I apply product rule, this is my first function and it's my second function. So applying product rule is mentioned here. Product rule. So that you understand. What product rule says, let us recall the formula. What product rule says, derivative. Okay, if I go with this, I want to find the derivative. So this is first function, this is second function. Keep the second function as it is, differentiate the first function, plus keep the, I repeat, to apply this, keep the second function as it is, differentiate the first function, plus keep the first function as it is, derivative of second function. Okay, or you can write derivative of f into g, both fine, no problem. So now see carefully, this is your first function and this is second function, correct? No. So here we are going to keep the second function as it is, then derivative of y dash will be second derivative, plus keep first derivative as it is, derivative of this root of 1 minus x. I am going step by step. Is equal to 1 is a constant, derivative of a constant is what? 0. Now from here we have to differentiate. See, there is no d by dx symbol, nothing but there's nothing to differentiate. Yeah, we have here. Now for this is of the form derivative of root x. Let's do one thing. First let's write this to root of 1 minus x square into second derivative plus y dash of. Now how to differentiate this? Recall what is derivative of root x with respect to x. It is 1 by 2 root x into derivative of this, correct? No, I said no, differentiate each and every term. So if I leave an arrow mark, means I mean to say if I leave an arrow, derivative of root x is what? 1 by 2 root x, 1 by 2 root x, and then I should differentiate x also. I hope this point is clear. Now same thing here also. Target number 1 is root. Derivative of root x is 1 by 2 root x. So whatever term is there here, no, same thing in denominator, into half it is. So 1 by 2, whatever term is there, that should go to denominator, into derivative of this term inside the square root. Derivative of 1 is 0 minus, because 1 is a constant. Here you are applying difference rule. Then derivative of x square is 2x is equal to derivative of 0 is what? 0 itself. Because 0 is what? Constant. Now we have completed the differentiation. Just we have to simplify. See carefully. What is 0 minus 2x? It is minus 2x. So very clearly 2 and half will get cancelled. What is remaining term? See carefully. Root of 1 minus x square into second derivative, then plus into minus is minus, y dash into x is y dash x divided by root of 1 minus x square is equal to 0. Always you have to see what you want to prove. Keep an eye on that. You can see there is no denominator here. We have a denominator. How to remove the denominator? Multiply the same term throughout the equation. Since we have got this term, so multiply by square root of 1 minus x square on both the sides. Again, I repeat how to know that I have to multiply. As you can see in denominator, there is no denominator for this. So here, yes, there is no denominator. Here it is there. When I say no denominator, I mean to say it is 1. Okay. So here we have, so to remove that, we are multiplying. So now you see, multiply root of this into root of this will be, what is root a into root a? What is root a into root a? It is a, provided a is positive. Okay. Okay. So when I multiply this, root of this and root of this, what? 1 minus x square will get into second derivative, then minus this root and this. If I got root a divided by root a, both will get cancelled, get 1. So similarly, this and this is getting cancelled. I'll get 1 into this y dash of x, and root of this into 0 is what? 0. Now check, have we got what is expected? See this term, yeah, here. Second derivative, yes, here. Minus, yeah, minus. Then x into first derivative, yeah, x into first derivative. A into b same as b into a, no problem, is equal to 0. Yes, we are done with the problem. 5 on 5. Okay, kindly make a note of this. Dear students, let us move on to the last 5-marker question from part D from model question paper number 3. Question says, if y is equal to tan inverse x the whole square, then we have to show that 1 plus x square the whole square into second derivative plus 2x into 1 plus x square into first derivative is equal to what? 2. Now, again, differentiate with respect to x. And you can see this one and the previous problem, both are on inverse trigonometric function. Okay. Now, when you differentiate with respect to x, derivative of y does not have any equation now. Y dash. Now see carefully how to differentiate this. This is resembling derivative of base is a variable, power is a constant, nothing but x power n. Now how you differentiate? Target number 1. If you think as arrow, first I should differentiate this. I'll get n into x power n minus 1. Then I should differentiate the base. Correct? No. So see, compare here. In place of n, we have 2. And this entire term is like x if I compare. So when I differentiate n, what is n? 2. Then whatever base is there, same thing should be retained. It is tan inverse x, then whole power n minus 1. N is 2. So 2 minus 1. Okay. Into derivative of the base. Base is here tan inverse x into derivative of tan inverse x. As I said at the beginning, even if you don't remember the composite derivative like f of x whole power n, from the basic formula also, if you remember the logic that we have to differentiate each and every term, we can avoid all those formulas. Okay. Now, since dy dx is there, differentiation is yet to complete. Let us proceed. Y dash, the first derivative as it is, 2 times of tan inverse x. 2 minus 1 is 1. And since power is 1, this remains as it is. Derivative of tan inverse x is 1 divided by 1 plus x square. Denominator is a variable. Avoid quotient rule. So to avoid quotient rule, make sure denominator should not be a variable. So this entire term we are going to cross multiply. So we are going to have first derivative into 1 plus x square is equal to 2 times of tan inverse x into 1 will be tan inverse x itself. Now we are going to differentiate again. So again, differentiate with respect to x. Now when we are differentiating, see carefully here, product of 2 terms. So this is my first function, this is my, the entire is second function. Again UV rule, UV derivative. So u is my first function, v is the second function. Keep v as it is, derivative of first plus, keep u as it is, derivative of v will be v dash. So here, keep the second function as it is, then derivative of first function, first derivative what? Second derivative plus, keep the first derivative as it is. We have to differentiate the second term. Here we have plus, so sum rule, derivative of 1 is a constant, so 0, then plus derivative of x square is 2x is equal to, here scalar and variable. So I have to apply scalar rule, keep 2 as it is, derivative of tan inverse x is 1 divided by 1 plus x square, right, divided by properly for you. Okay. Now again, as I said, no, always keep an eye what you want. Do we have anywhere denominator here? No. You see, there is no denominator, nothing but 1 in denominator is there. Here also, denominator is 1. Here it is 1 plus x square in denominator, which is not there here. So what we will do? Cross multiply, or I can say multiply what? 1 plus x square on both sides. Now again 1 plus x square into 1 plus x square. What is a into a from school days? Say me, what is a into a? A square. So 1 plus x square into 1 plus x square will be 1 plus x square the whole square into second derivative as it is. Then plus y dash 0 plus 2x is 2x into, don't forget I should multiply throughout, so I multiply this term, so it is 1 plus x square is equal to 2 times of, when I'm going to multiply, okay, 2 into 1 is 2 divided by 1 plus x square. Let's show that step. So I'm multiplying what? This term, correct? No. Now see carefully. 1 plus x square is going to get cancelled here. So what is remaining? 1 plus x square the whole square, second derivative, plus either if you want you can write in this manner, or you can write it as it is. Both are same. It's commutative. A into b same as b into a is equal to 2. Have we got the result? Check it out. This term is here. 2x, yeah, 2x. 1 plus x square here. Then first derivative is equal to 2. Yes. So with this we have completed all the 5 markers. Kindly make a note. Yes, dear students. Yes, dear students, we are with the last problem on this chapter. And this second derivative problem has come for 1 marker in fill in the blanks. Okay. So let's go ahead. I have to find second derivative. So differentiate this with respect to x. So first derivative minus, so difference rule. So I have to differentiate this and this separately. Here I have got 3. It's a scalar rule now because 3 is a constant. So keep 3 as it is. Derivative of cos is minus sign. Bracket is mandatory. Many will just keep as it is. It looks very clearly difference of 2 terms. But here it is product of 2 terms. Don't even give dot. Give a bracket. Have a bracket practice because bracket is very clearly saying no. These are product of terms. Then minus 5. Sine derivative is cos x. Now see this. Okay, I want second derivative. So again, differentiate with respect to x. When I differentiate again with respect to x, see carefully. Second derivative is equal to 3 as it is, minus also as it is. Derivative of sine x is cos x. Then minus 5. Derivative of cos x is minus sine x. So second derivative plus into minus is minus 3 cos x. Minus to minus is plus 5 times of sine x. See, left hand side you have 2 terms. Fine. Let I just transpose this and see what happens. Second derivative. Minus will become plus. And this plus will become minus. Is equal to what? 0. Now observe this entire term with given question. 3 cos x minus 5 sin x. Nothing but it is y. Second derivative plus y is equal to 0 from equation number 1. Yeah, second derivative plus y is equal to 0. So in the fill in the blanks, the value of this is what? 0. So with this we have completed the chapter. From this chapter all the model question paper problems. Okay, kindly make a note. So dear students, with this we come to an end on continuity and differentiability with respect to concept. All the concepts are discussed clearly. I have made an attempt to make it as simple as possible. And good thing about the paper, the way the questions were distributed, all the concepts are discussed. Okay, so make sure study well, do well. Okay, I think now just 38 days or more for 28 February. So we are just coming closer to examination. So you have to be ready to hard work, be dedicated. Each and every second is important. Okay. All the very best. Do well, study well, and God bless you all. Do share, like, and subscribe to my YouTube channel, Math Universe with Dr. Naseer Ahmed. Thank you.